Hello, all. I'm John Quinn, Director of Science and Product Development at FlowJo, aka BDB Biosciences. Today's monthly webinar is going to be an intro to 11.0.2. We put out an 11.0.2 release that just had a few minor updates to the messaging involved with the BD Access portal, the tool that you use to sign in with, so that it didn't just say contact support, whether the problem you were experiencing had never signed in, didn't have a license, all that stuff. So the messaging should be a little clearer in 11.0.2. We are prepping for the release of 11.1 later this month. Should be right about at the end of the month. And so this will be the last webinar on 11.0.2, and I will cover just at the end of the slides I'll show what the features that 11.1 is going to get. So without further ado, let's share a screen and do some slides. Okay. I like to start a V11 intro with some of the rationale behind why we have an 11 as opposed to just the next version of 10. What the primary differences are between 10 and 11, a little bit of a how to use it, and then we'll break out a live demo where we actually bring in data and I step through how to analyze the data. So there is my contact info, john.flowjo@bd.com. You can reach me there. And now let's go. All right, so we decided it was time to make an 11 and start from scratch compared to version 10 because we wanted to update the code base to a modern language. I think it was time to improve the performance, getting away from Java, which version 10 is written in. And while we were making a brand new version, we figured we could change the focus a little bit. And so making enabling comparison an overriding design goal throughout the program. Every bit of the program that we've looked at, we've said, well, how does this enable comparison? And so that's the primary thought process here. We've also tried to build in more tools for automation, and we wanted to write it in a language that builds the foundation for cloud computable, cloud compatible computing, which is not in yet, to be clear, but is something that we have on our roadmap for as soon as we can possibly do it. So that's why there is an 11. I want to point out that you can, if you've got a portal license for FlowJo, you can use 10 and 11 simultaneously and just as part of the same license. We're now a subscription software, so it doesn't matter which version you want to use, either one, 10 or 11 is going to be fine with your FlowJo portal license. So we feel like 11 at this point, it was worth releasing in that there are people with some workflows, essentially people with high dimensional data that they'd like to analyze, maybe very large data, maybe spectral data, and they're okay with the choices we've built in for automation, tsne, xshift, etc., as opposed to wanting all of the tools that are available as plugins or just built-ins through version 10. And so if you fall into that category, 11 might be right for you. If not, version 10 might be right for you. Okay, so what are the changes in 11 compared to 10 that may make it interesting for you to try out? All right, so number one, we have login via the BD Access portal. BD Access portal is a tool that will hopefully in the future be used for logging into all BD software. We are the guinea pig. And so it'll be slightly different. It used to be the FlowJo Access portal that was built into V10 that you signed in with an email address and password. Now you sign in with an email address and password, and the same one is fine, but it is a separate software. We've made it immersive. So one of the primary requests I have regarding improving 10 was to get away from using many, many, many windows and put it all in one big window. And so that seems like that's been a popular change so far. We've added some different themes. You can now work in dark mode. You can work in 5 different versions of dark mode. I think that's nice. Helps avoid the eye burn of looking at a white screen all the time. We've updated the sample hierarchy. And I will show one slide on each of these and then also demo them. So I'm going to go through this pretty quickly, just to make it a 3-part hierarchy that I think is a little easier to get to the exact population and sample you want to. We've added new contexts. So the way that this tool is set up now, the action happens in the middle, and to the left and the right are your supplies, your organization, your files, and then your tools. So we've set it up like a workbench, and hence the name of the files are called workbenches. What's happening in the middle of the screen we refer to as a context. And so there'll be a series, and I'll show you the next slide what those are, a series of contexts that you can choose from to control what the middle of the screen is doing. We've added a new one called the Metadata Manager, where we've made handling metadata like a primary tool. I think it's super important to have well annotated data. And so that is now in there. And included in that is a tool called parameter sets, which we've never had in FlowJo before. We did use them in SeqGeek because there were so many parameters in single cell sequence data. But particularly with the FACS platform and all the imaging parameters, or with AbSeq data, or with SciTOF data. There's just tons of parameters, and we felt like it would be really useful to be able to let users create subsets of parameters that they could access and use repeatedly throughout the program. We've built in QC. I'll show you that. We've added a modern unmixing platform. There's something in it called the adjustment matrix, which I think is a very nice addition if you happen to be working spectrally. It's the ability to make, if you have to hand correct, and we generally recommend against it, but if you have to hand correct, it allows you to do parameter correction on a 0 to 100% scale, as opposed to attempting to figure out which detector is the primary cause of anything you'd like to correct. We have a graph gallery now. So rather than all the windows that pop up, we needed a way for you to look at many different views of your data all at once. The graph gallery is a flexible tool that allows you to look at all the samples or all the parameters or the ancestor right now, and we've got more coming. We will keep using that for all sorts of stuff. It also includes virtual concatenation. So in a typical high dimensional workflow, what we've always recommended in version 10 is that you concatenate your data at some point, run an algorithm on a representative example of your data so that you can then build common sets of parameters or common clusters or whatever it might be for all of your data. And then maybe you can forward propagate the results by using the embedding tool. Well, this tool virtually concatenates everything. You don't have to make a concatenated file. It'll just treat all the data in a given group, whichever one you select, as concatenated, allow you to run whatever algorithm you want on it. Those algorithms include downsampling options if you want to run them faster, and automatically upsampling, so the embedding tool is built into that. So I think that is a real benefit to the high dimensional workflow. We've added a built-in clustering tool, XShift. It's a good one. So if that one works for you, then you can use it without having to deal with any plugin. We have auto-batched our tables now. So if you drag in information that tells us what the rows are, a set of samples, for example, and the columns are some populations, it auto-batches. And that's that. Makes it easier to do tables. We've added charts. If you want to take a full, this doesn't have to be high dimensional, but I think it really helps with high dimensional workflows, and show the summary stats at the end. We can do it in chart form built into FlowJo now. We've changed the layout editor to just reports. We've tried to make the way you will output your results a little bit more page oriented, so you can set it up as a report, as a PowerPoint, as whatever you'd like to do, as a PDF type thing, with the right shape and format, etc. We've added some new batching options to reports so that you can batch across a set of subpopulations. So if you want to take clustering results and batch each one of the clusters, you can do so now. You can also iterate and threshold based on statistics. So you can set some kind of statistical level of interest and make sure that the batching includes only files that meet that. We've added built-in support for imaging. So we have imaging that all you have to do is have the images on your computer, locate it in the file structure that FlowJo 11 and Course, the same one as they expect, and then you can just see images. We do not have all the tools yet for imaging that version 10 does in the Selvulence plugin, but we will soon. And so this is going to be, I think, a better experience for imaging in the very near future. And we've modeled our preferences after V10's advanced prefs, which were a late addition to version 10. I think the advanced prefs came out, I don't know, maybe it was 10.9, maybe it was even 10.10. I don't remember for sure. But I really liked them. They were well done. And so we've just started with that preference model now in V11. All right, so let's look at one slide on each of these. BD Access Portal. When you download FlowJo 11, it is packaged with another software called the BD Access Portal. Install them both into applications. Start the BD Access Portal. Sign in with your email address and password. It'll stay running passively in the background. After that, it should work exactly like the old FlowJo Access Portal did, and that should be that. As of 11.02, there are also now through the little 3-button tool, there is a way to add proxy settings as well if you work behind a firewall. All right, the application's immersive. So this is just a screenshot of my entire screen using FlowJo 11. It fills the whole screen. The primary parts of it are shown here. So Starting over here on the left is the navigation bar. And each of the elements in the navigation bar is a context. And I imagine you would go through an analysis by going one after the next down the left-hand side. So you might add some metadata, you might do your quality check, you might compensate or unmix, you might look at graphs and do some gating, you might then run a platform like a t-SNE, for example, you might then create some tables, some charts, and then finally put together a report. And then at some point, it's stuck right at the very bottom, there is a preference tool, so you could adjust the preferences. This window here, or this portion of the window, is the analysis tree or the analysis hierarchy. It has groups, populations, and samples as three separate components, and you will choose them in concert to see what you would like to look at. Groups will filter what populations and samples are present, and then clicking on a sample and a population gives you that population for that sample. And I think that saves a lot of scrolling looking for the proper population on the proper sample. So I really like this. It is also the selection tool used throughout the whole program from almost anything. If you want to run something or point to something or load something on a population and a sample, you just do it directly from the analysis hierarchy. And we've done away with any kind of window or drop-down menu that requires selecting a population or a sample in some way. So keep that in mind when you're trying 11. The hierarchy it's the primary way to do any kind of population selection. If you're looking to change the view of a particular population, try clicking it in the hierarchy. In the middle is the discovery pane. So it's showing the primary graphs in the graph gallery right now, but it will also change with whatever context you select. So this is, again, it's like a workbench. The middle is where the work happens. And then you've got your materials on the left and your tools on the right. The tools being a variety of properties panels that will adjust to whatever context in the middle. It'll give you a set of tools that are germane to that particular context so that you can do the work that is appropriate for what context you're in. Okay, I mentioned we had themes. So right here under the top menu, there's a themes button that allows you to pick, I don't know, a variety of dark modes, a variety of light modes. Veronica so far is the most popular of our themes, a sort of blue-purple kind of mode that catches the eye and has made the person Veronica, who asked for those colors, very proud of her work. Okay, the sample hierarchy. Described briefly in the context, but it is the group panel, which is right here. The group panel selects and filters populations and samples. So if I pick a group, it only shows me now populations that have been applied to that group and samples that are in that group as well. It is hierarchical. We have added the ability to add multiple groups in a hierarchy so that you can do things more like how you think about your experiments. If you've got a gate you want to add that should impact all samples, you can drop it to the experiment data level. And then if you've got two separate conditions, healthy, diseased, whatever, and you want to make some gates that are specific to one or the other, you can then go work on that, having already had everything that was upstream on the experimental data group filter down to it. I do want to point out that the top level is now acquired data as opposed to all samples. Felt like the appropriate name, saying that we were going to add one immediate distinction in the data of compensation data versus experimental data. So similar to version 10, where there was a compensation group that looked for the word comp and unstained and so forth. If you have comp data, we immediately separate it from the rest of the data. So that's new, that it actually separates out and goes to the comp data group, and that the comp data group will have subfolders for every experiment you drag in, assuming that we can find comp controls for those experiments. So if you have things that are annotated with the word comp and divided up into folders by experiment, you should just be able to select a single folder and hit go and run compensation or unmixing for that given experiment, even if you've loaded many different experiments into a workspace. So I hope you find that like a nice improvement. The population panel right here. So populations are associated with a group. So we found that almost everybody's workflow in 10 was to draw a gate and add it to the group so that they could do comparison. We said, well, if we're all about comparison, let's make sure that every sample in the group just immediately gets a gate. You can still adjust any gate individually at any time. So you're not forced to have some kind of uniform gate for your samples. But I think the process of making your gates just group owned make it easier to filter them so that we're always showing a set of gates whenever you pick on a group that are appropriate to the samples in that group. And it makes it a little easier. Anyway, you'll notice that these go bold if you move a gate on one of the samples in a group as the indicator that something has been changed. There has been a one off or two off, whatever it might be, adjustment within your data. There's also this little see all mode button I'll point out right here. So we will filter, as I mentioned, the populations to which ones are associated with the group. So you can imagine that if we had these gates, bad events and good events associated with experiment data, and you had made a gate on multi-disease, you might not see it right here if you're clicked in experiment data. If you just want to see all the gates on every single file, you hit the see all mode and it shows them all. So up to you. You can toggle that back and forth depending on what makes the most sense to you for the given experiment. We have see all mode off by default for the time being. We're learning, we're listening, we're seeing what people say. Maybe we'll turn that on by default if it turns out everybody wants to see all the gates all the time. The sample panel shows individual samples. So if you want to then pick the good events on a specific sample, you just click good events and you click the sample, and that's what you have in the primary graph or whatever other context you're working in. No more scrolling looking for the good events on a particular sample. Okay, Metadata Manager is a 3-tab section for handling metadata. The first of the context as we move down. There's metadata controls for keywords, parameters, and parameter sets. Probably the most interesting part of keywords is sure you get a list of keywords. You can pivot the table. So couldn't decide whether it was most useful to show a long list of all the samples and then a relatively compressed list of few keywords because you run out of room going to the right, or to hit the pivot and show all your keywords going down and a list of samples as rows. So click whichever one you want. That's another one that I guess at some point we'll add a preference for that. We haven't done that yet. That allows you to make it work as you want by default. There's also ways to filter by keyword or by values of the keywords. You've got a tool right here that allows you to type enter keywords. So if you want to put a new keyword in, you can do so. Coming in 11.1, the ability to import keywords from a spreadsheet. Parameters tool shows you a list of your parameters, allows you to rename if you want. Parameter sets gives you the ability to group together parameters so that if you wanted to only have, say, your immunophenotyping parameters shown in a list, you can do so. You pick the things you want, hit go, it becomes a parameter set here. And then throughout the rest of the program, parameter sets are an option that can be used for selecting for clustering, using as your drop-down menus on any plot. That's perhaps the tool that if I go back and use 10 at any moment, I say, oh, I wish I had the most, probably. Anyway, there's built-in QC. I'm going to hit the play button here. The idea is that we had a bunch of plugins that would run QC in version 10. And so we took one similar to FlowAI, an approach similar to FlowAI, which checked signal stability, flow rate, and cells on the edges of the dynamic range, and built it right in. And so that was a real-time run that I just did on 48 files, sorry, all 20 in experiment data that had about 30 parameters. And that was the time it took to QC all of them. So I think we've really expedited the QC process, that it takes about as much time to run QC on an entire experiment as it did in one file because we don't have to deal with plugins, and we've made this faster. So boom, I think that's a giant time saver. If you want other QC tools, we will at some point either build some of them in or connect the plugins back. I've spoken against plugins a couple times. I love plugins. I saw that on the Reddit thread that someone was like, the FlowJo people hate plugins. I love them. They're just a little hard to give out and maintain, particularly for anybody in a regulated environment. So I hope this makes it easier for you folks who don't maybe have admin rights on your computer, and we will figure out a good way to make plugins happen in the future where you don't have to control that. So for now, if you want to QC, it's just a button, does it all. Everything that's in experiment data gets QC'd. You get a good events and a bad events gate. Carry on with your life at that point. Okay, modern unmixing platform. So you will click on whichever experiment that you want to use for unmixing, hit go, and we will do the bit where we try to figure out which parameter goes with which control. We will automatically gate them. By default, auto spill is on. So auto spill is a linear regression based approach to doing unmixing or compensation. We've got some webinars on it. If this is the first time you've heard of it, they're worth watching. I think it's a really nice thing to use in that it alleviates the need to make positive and negative gates. as it's using linear regression as the target for is this data properly unmixed. So it's a little more robust, a little more repeatable, a little more automated. It also has an optimization tool built in, so it should work as well as it can work first time without much effort by you. All you have to do is make sure the cleanup gates seem reasonable. And that happens automatically too. So anyway, auto spills on by default. And so you've got two plots down here, one that shows the cleanup gate for the selected sample. We've changed this, so now we're just showing one row of plots, and you can click through any one of the files and that will dominate what's in the plots here. I think that makes it a little more convenient, a lot less scrolling again. We were trying to do less scrolling for this version. You get a spectral plot. You can collapse or hide any one of these panels to make it fit your screen. If you don't want to do spectral, there's just a button for traditional. If you don't want auto spill on, there's just a slider for auto spill off. So it's easy to turn on or off. I think this is a nice set of defaults though. You have controls over negative and positive populations down here. If you have auto spill on, it'll just be the primary population since it just is the cleanup gate then, since we don't have a positive and negative gate in auto spill. The ability to rename a parameter. You've got controls over here where you've got a colored circle and a checkbox. Unchecking the checkbox means we won't build a parameter from that particular control. Unchecking the colored circle makes it a grayed out one that tells you this could be used as a universal negative. So you can select as many different samples to fall into the universal negative category as you want, which I guess makes them less universal, but still common negatives, maybe? Maybe that's the right word. And anyway, they will appear under the negative population dropdown. So anything that you uncheck from the colored circle is now in a short list of things you may select as a universal negative. So if you've got some kind of negative bead or negative cell, unstained cells, you can highlight them both, use them where appropriate. Hitting the preview button brings you into the preview view of your matrix. So we have attempted to redo this to make it a lot more easy to read, more visible. One of the primary complaints about 10 is that it was designed in a world where people generally did 8-color cytometry. And so looking at all of the plots in the diagonal, half diagonal triangle was pretty tough. So we've made it now that it's filtered by a specific parameter, and you see every other parameter versus that one. There is a checkbox for show other detectors so that if you're in a spectral situation, you can see what the spill is into any detector. You can turn that off if you just want to see parameter by parameter interactions. You can choose dot plots or contours, and the hierarchy works as your selection tool for what you're filtering down here. So if you pick on a full stain sample, you'll still see the full stain sample. If you pick on a gate that has removed the dead cells and debris, then you'll see pictures of what the cleaned up population looks like with this matrix applied to it. So I think that's a really nice way to use the hierarchy to be able to navigate through anything you want pretty quickly without coming or going from this platform. You can also choose a variety of ways to view the numbers up top. So right now, this is just showing the spillover matrix. You can also switch to an SSM. You can switch to a similarity matrix. If you haven't used autospill, you can get the total spreading matrix. No one has yet invented the TSM for autospill, a job for the future. You can heat map them or not. You can hit go to create the matrix here, or create matrix to create the matrix, I should say. The button doesn't actually say go. I just think of it as the go button in my mind. And then if you have a matrix that you want to edit, you can either edit directly the spillover spread, or there's this unmixing correction matrix, which just is, again, 0 to 100%. And if you hit it 100%, everything's in the diagonal. Anything less than that, and you'll see it spread out. So I think it makes it a lot more sense to edit a spectral matrix using that tool, which I think is a nice innovation for this platform. Okay, graph gallery. We will show our primary graph here. It is controlled by whatever you select over here. You can promote any plot from the bottom by just double clicking on it, and it becomes the primary plot. The primary plot has your gates. It has your advanced, next, up, down the hierarchy. It's got axis selectors here and transformation axis buttons next to each axis. All your tools pop up on the right. So if you hit the T button, you get this to pop up. You could also hit the T button directly from the right. So on the right, there are controls for what parameter set do I want to filter one of my axes to, what kind of plot do I want to look at, what kind of transform do I want. So all that stuff is just always present on the right. You can expand it or collapse it using the little 3-line button over there. Up to you. So you can allocate as much room as you want to plots and as less room as you want to controls, or more, depending on what you were doing at any given moment. The gallery down at the bottom is either in graph gallery or image mode. And then if it's in gallery mode, you've got a variety of ways that you can choose which plots appear. We've tried to make it thoughtful and organized, no matter what you do, as opposed to random selection or pinning or anything like that, or dragging and dropping. I think that was a good way to go, and that it should always make sense then what plots are being shown. Here it's being shown by sample, so for a given population that's selected, you see that pop for all the samples. There's also the option to view it by parameter, so for a given selected population, you're seeing all the parameters. There is an ancestry tool that shows you for a particular population. How did you get there? By looking up the gate tree, and backgating is coming in 11.1, as well as the ability to change the target of what is shown down here so you can make it different from what's in the graph gallery in case you want to like move a gate and see how that affects your per sample, ancestry, or per parameter plots. One more click here to show, oh yeah, that's the primary plot. And then here's what it looks like if you've picked image wall instead of graph gallery. If it's fax discover data, you get pictures down there. I'll also point out that there is an image control button right here that gets you your image filter tools. Sorry, I forgot I also was like, and here's images, as if that wasn't kind of obvious where the images popped up. Oh yeah, and here's where you have the controls. All right. Next button down on the list of contexts is the one for algorithmic tools, or platforms we're calling it. There is X-Shift and T-SNE that are built in. They both use virtual concatenation by default all the time. So if you want to run it, just pick whatever group you want to work with and you're good to go. They have downsampling and built-in embedding. Okay, tables are auto-batched. So I've got a little picture, or sorry, movie that just showed dragging in a group. And so that's going to populate all the rows of the table. Here's the samples I want to see. Dragging in a population says, here is the population I'd like to see. And then there are default stats you can choose. So it can either be a count, a frequency of parent, a frequency of total, or both, or all three, whatever it is that you prefer. And then what the movie just showed was that in the properties panel where all the controls are, there's also tools to like multiplex. If you want to pick a median and pick a whole bunch of stats, or a median and a CV and pick a whole bunch of stats, you can create a whole bunch of columns for your table right away. There's also a control on the right for what summary stats do I want. So mean, median, max are all being shown by default. Okay, charts. I'm going to hit the play on the movie like this. Charts are all based off of tables. So if you have a table and you open up charts, it says, well, here's the table you're using. Which stats would you like to turn on? What keywords do you want to use to organize the data? So this all just works by checkboxes. So you can see here in the movie that I've got the keyword condition turned on, and I'm turning on and off specific conditions. So I've made it just a comparison between healthy and SARS. And then I go in here and I choose how to display it. So I'm creating a t-test at this point, showing what the basis is that I'm comparing things against, what my thresholds are for significance, and whether I want to show those lines that show the comparison, show a p-value, things like that. I want to show the error bars. All that kind of stuff is built in. So these are live. You can update a gate and your chart will update. You can add your chart to a report. I think this helps complete the high dimensional workflow in a way that V10 never had. Okay. Reports replaces layouts. I feel like I was talking a little slow during those movies. So let's see how I do here. So the basic gist is you just drag and drop whatever you want into report, just like version 10, except that now you've got the hierarchy and the report fixed, so you don't have to try to like arrange your screen so that you can see both at the same time. This is showing an overlay of a cluster versus all the events from the parent population, and it's showing that you could batch by population. So I'm using this particular example to show each cluster one at a time on the t-SNE plot. You can add pages. And so again, it's a little more page oriented. So if I wanted, I could have that batch from showing all the different clusters, but then I could add my table, I could add my charts, I could add the top level population. So I could build a summary page that had at a glance what was in this work. And then you can also set that page to not batch. So you can build a multi-page report that has particular pages that are more like summaries, not batch, and then the rest that are going to show a common set of plots, all batch, so that you can control what you want. And you can control what you want in a variety of page sizes and formats and so forth. This is also live, and if you noticed, it was just a toggle button up top. View batch or view source. Go back and forth. If there's anything that you look at in your batch, you're like, well, I didn't really want it that way. You can go back to source, change it there, hit batch, and you'll see the updated batch. So we don't build a ton of different batch reports. It's just how you want it at the moment, and there's a save as button that breaks off a report, fixes it essentially. If you're happy with the way that one works and you want to start building other variations, you can do so. So I think this simplifies the whole process of building reports. You can let me know. Okay, and on to the next slide. All right. Um, as you've got a preview already, when I mentioned that the graph gallery also showed images, we've got built-in support for facts discover data. Moving on. Preferences. We've got a few different preferences, and actually there's now more as of 11.02. This is still an 11.0 slide. We've added a couple more that control things like how many decimal places do I want to see and whatnot. But the most important part about this is that you can set your prefs per cytometer, and then you can build as many different rules as you want for that cytometer in the style that V10's advanced preferences were. You can say things like, if you can find a parameter, it's called forward scatter, make it linear. If you can find these image parameters, then treat them like image parameters and put them on the scale that's appropriate for them. So I think that's a much nicer way to handle preferences. The other thing that I should mention about preferences in V11 is that they are also hierarchical because we're cytometrists and we love hierarchies. You've got machine, user, and workbench preferences. So if you set a machine preference, the machine refers to your computer at that point. So everybody who walks up to the computer gets this set of preferences, unless you, the individual user, set some user preferences, which then take precedence over machine if you log in as yourself. And that's what all of your workspaces get, those preferences, unless you, the user, have a workbench that you want to be different in terms of what its preferences are from your typical setup. So if it's the extreme outlier, this one workbench should just have its own set of prefs that are different from everything else I've ever done. Cool. Set some workbench prefs. And then you've got very fine levels of control for the preferences. Okay. So 11.1 coming later this month. We're in the final stretches where we're fixing a few bugs, saying our QC, and going to release it to you. What this one's going to include is the ability to open V10 workspaces. So 11.0.2 and all previous versions export from 11 to 10. If you were working along through 11, you found there was something you wanted to do that wasn't yet in, like, oh, my cell cycle model isn't yet built in. Save as a V10 workspace, continue on. It didn't occur to me that people would really like to use 11 by starting with 10 workspaces. And so it took till 11.1 to build in the ability to read some V10 workspaces. What will be present in 11.1 is the ability to get your groups, your gates, your organization, your comp matrices, parameters that you created, such as I ran a t-SNE, I ran a clustering algorithm, all of that in. We are working on how to do tables as the table format is different. V10 had the table definitions. V11 just has a table. So we have to like auto build the table, coming probably more like an 11.2 thing. And then what to do with reports, which are completely different in terms of how they're written and stored, working on that for some future version. But at the very least, you can start with all your gates and such an organization done and start out with a V10 workspace in 11 to continue whatever you're working on. We're going to just natively support CVW files in 11 so that if you bring in the compressed waveform file, 11 just allows you to see the pictures. You don't have to carry around the extracted images, which can be, kind of large. We've added keyboard accelerators. If you're a keyboard person, this one will allow you to just work on your keyboard, hitting a variety of command, this, that, and the other things, making everything happen. So, I try to not use keyboard accelerators too much while I'm demoing, but I love a good keyboard accelerator to speed up my work so I don't have to like move around and drag things, etc. The transform panel is going to be included in the unmixing wizard so that if you get into the unmixing wizard and you think, oh, I needed a little more space on that axis or a little more compression there to make a proper cleanup gate or to previs data, it's there. It's just built in. You can work all within the wizard without having to leave it to do any transformation. I think that's a nice improvement. You can do keyword import, as I mentioned in the slides. Backgating will be built into the graph gallery. We're going to improve the facts discover support to handle bigger, heavier, more fun facts discover files, and we will add quick exports, a way to very quickly take any part of the program and copy it and paste it from the clipboard so that you can get things out a little bit more easily. All right. That is 11.1, soon to come. Longer term thinking, just so you know where our thoughts are. In the short term, we realize that the Cluster Explorer would be a great tool to have in 11 to go with all the rest of the high dimensional workflow. We'll make that a top priority for 11.2. We also want to expand the image analysis tools to match what the CellView Lens plugin from 10 has. It's got some really cool stuff to do image analysis with. We need to get that into 11. And we have heard from everybody that histogram overlays and other controls for organizing histogram displays are super important. So we'll get that into 11 too for you also. Longer term, we still have to come up with a way to give you the option to do cloud compute. We feel it's our responsibility to have a desktop-based program that you can pay one price for and use for as long as you want, as much as you want, without any limitations and so forth. Helps with the budget and helps if anybody's not doing immense data sets. I think it's a good thing to always have, but we do want to offer a cloud option for those who have really, really big data sets or very complex algorithms to run. So working on the best way to, I mean, amongst other things, just figure out what level of cloud support we need to have and how much to charge for it and whatnot, so that we don't go broke giving out cloud compute as an option. If you're interested and you have ideas on what those limits are, I'm happy to hear them. We need to solve plugin handling. I think it goes with the cloud compute option that if we park all the plugins in the cloud, then we continue to have the ability to make FlowJo extensible to just keep an R environment and run the R-based plugins without having to like recode them all, and allow you to build R-based or Python-based plugins and use them in FlowJo. And then if it's in the cloud, then we can control the environment, keep it updated and whatnot. You don't have to download anything. I think that's the right way to go, to build in at least one kind of every tool right into the software so that everybody has access to a full workflow, but then continue to make FlowJo super duper extensible. We want to add pipelines. The software is already set up to run a series of actions in a pipeline. It just needs a little bit of automation control. So we'll do that as soon as we can. And then there's tons of platforms that would be nice to put in. So cell cycle has to come at some point, kinetic proliferation, everybody wants UMAP, things like that. So that's our long-term thinking and where we're going with version 11. All right. And at this point, I'm going to demo unless there's anything in the chat. Let me peek at question-wise. Nope. Or the Q&A. Also good. So, all right, let's just demo. Oops, there is my Zoom. Okay. So I added the data set that I used making the slides into FlowJo. So this should, fingers crossed, jive very well with the slides we just looked at. It is a multi-disease data set that I got out of the Flow repository that has a series of full stain files for different respiratory diseases, COVID, flu, RSV, and then a healthy control group. It's also got comp controls that are built in, a 28 color panel, so fairly expansive panel, something like 1 million to 500,000 cells or so per file. Controls for what's happening in the work, and sorry, in the hierarchy are right here. So add stats, add keywords, add groups, add samples. Contexts are right here. So let's start walking through the context, as we expect that's the way that people will go through an experiment. I'm also going to move my face in Zoom. You can't see it, but I'll put it down out of the way of some of my controls. So Metadata Manager. Right here, we can see a list of all of the samples and some keywords moving across. If I pivot it, now we have a longer list of keywords that we could see and scroll through, and samples scrolling across. This is always expandable and collapsible if you want to allocate more room, and you can add a keyword here if you want. All right. And the Zoom controls get out of the way. I'll click on parameters. So list of parameters, editing them is just a matter of hitting a pencil, and you can edit what you want. Parameter sets, let's make a parameter set. So if I go through and I highlight a handful of parameters, let's go pick out some functional markers, for example. Good enough. I can say add selected. I see the list appear here. I can give this a name. Functional markers. Give it a description if I want. But now that set of parameters exists throughout the software. So if I'm looking at graphs, for example, I can either click the parameter sets button here, and X, Y, or color axis can be controlled to only show, for example, the functional markers. So there's the X axis now. Limit it to just that small set of parameters. And you can also do that right from the dropdown. So there's a place to go from functional markers to all if I want, and put forward scatter back on. So up to you. Clicking X, Y, or color axis controls which of these axes you are setting up a parameter set for, and doing it directly on the axis, I think, is pretty straightforward. So those will appear throughout the rest of the program, like if you run a T-snare, an X-shift, etc. If we want to pick something out in the reports, just a great way to get down to a more reasonable subset if you've got a focus area amongst all your parameters. So if you do a bunch of immunophenotyping up top and then never want to look at those again while you explore a whole bunch of functional markers, great way to simplify your workflow. So that was metadata. QC, hit the QC button, choose parameters to adjust and apply. By default, everything's selected. If I turn everything off and say, I just want to look at the fluorescent markers, I can do that. You can see that we're checking signal stability, flow rate, and dynamic range. Turn off anything you don't want to check, but typically I leave them all on. You've got some tunables there. I will remove the outliers and then say apply. And that'll think for, as we saw in the slides, something like 20 seconds. And then everything in experimental data will be QC'd. We're going to get plots appearing in the middle so that if you want to inspect any of your samples for what was QC'd, good and bad, it's right here. So of X I show here of maybe are showing a moment of instability. And then if I want to see a different file, I just pick the next one down in the list or whichever one that I want to look at. So that is QC like that. And then you get a good events and a bad events gate on the experimental data group. And you can just start working in good events from here on out. So QC. Unmixing. I'm going to select my comp controls. At the moment, it's unmixing on the experimental data. We don't want to do that. Let's do comp controls. It's telling me I'm doing comp controls, and I will make a matrix called matrix, which I can rename later. I'm going to hit next. And so this will be the pairing process where it's going in and it's matching each control with a parameter. I can rename that. It's telling me what the parameter detector is. It's auto spill, so there's a primary population and no negative population. We updated this at some point to show a positive gate and a positive population even when it's auto spill, so that the spectral plot here is of the positive population. It just wasn't a very helpful spectral plot if it was the negative and the positive. So that is why you see a positive gate here despite auto spill being on. Question in the chat. I'm performing image cytometry experiments. I say it was intrigued by the fact that you will integrate the capabilities. Do you have an idea when it would be possible to have all possibilities of BD Cell View Lens in version 11? We are intending to get essentially all of the tools. I think we'll see as many of the tools as we can into 11.2, which we will begin working on as soon as 11.1 is out. It is one of our primary goals. So yeah, I think if you are interested in having early access to it, write me at john.flowjobd.com, and sometime over the winter into the spring, we'll probably start having beta versions that include an expanded set of image tools. Okay, let's see. I think the things that I want to demonstrate here, I think one of the most important ones is that if you've got this size gate, and we tend to make pretty tight size gates by default, and you think, I'd like to edit it, the easiest way to do it is to just start drawing. So if I just start drawing, whatever I draw will just replace the size gate for that file. It's much easier than like trying to drag each of the individual nodes somewhere else. So keep that in mind. If I also want that size gate to be applied to all of the samples, and I think there's some variety. I think there might be some cell controls in here. I could apply the gate to the group, or I could apply the gate to the group and resync all. So the difference between those two choices is one applies to the group, and any samples that you've individually modified are remembered to be, unique variants, and we leave those alone, versus and resync all applies this gate to every one of the samples and overwrites all the variants. So up to you what you prefer to do, but you could do it right here for either the size gate, the positive gate, whatever. Okay, there's that. Uncheck a box if you don't want to use a control to make a parameter. So this would still be available to use as the universal negative or something like that. And you can also, if you turn off the color, you see it goes gray, or in this case, a pale blue since it's Veronica mode, and it will appear in the drop-down as a potential for being a representative negative population for many samples. So I'm going to use it here for now, as we actually could use it. But that is the gist of the controls while setting this up. I should mention you can hide and expand any one of these plots. You can use the scrolls to go through and look at your data. Yeah, there was definitely at least one cell control in there, probably live dead. Okay, so that's the setup. If I turn these on or off up here as well. If I move my zoom controls and hit preview, then we will calculate a preview of the matrix. At this point, I can allocate as much of the screen as I want to looking at either the numbers or the plots. And some zoom in and out works as well, so I can get a pretty good sized matrix all on the screen. This is 30 by 30 right here. A little harder to read at 30 by 30 resolution, but I can get a lot of it on there. And then I can also choose to go all the way up with this or collapse this if I want to give primacy to the plots or the numbers. All right. At the moment, we are showing B515 versus all other parameters. We can switch it from a dot plot to a contour. We can, let me open this back up. We could switch over to full stained and look at a full stained file if we wanted. If we had gates on these, we at least have good events. We can switch to good events, and you can see it's telling me we're previewing COVID-4 good events. If I show other detectors, if I'm spectral, that I could do that. I did not do spectral for this one. We could overlay the uncompensated if we want. There's what it looked like uncomped. So bunch of different controls there. Up at the top are our visualization tools. So we could do SSM. We could do no TSM because we used autospill. We could do a similarity matrix, so 0 to 1 associates between the parameters. How similar are they? We could turn on or off the heat maps. And back to compensation spillover. All right. So there is assessing your matrix. When you're happy, you say create matrix. Right here, we have our compensation matrices. So we've got the acquisition defined, and now we have matrix. If you click one, that's what you're looking at in here. So they're actually pretty similar. I think, see, one number go from 7.5 to 8, and that's about that, 7.4. A couple other, I guess, one decimal place changes, but really similar results from the acquisition software and FlowJo at this point. If you want to edit the matrix, you can hit the edit button. You get this message that says, maybe don't do this. If I say I'm doing it anyway, then we have an editable matrix now. But I like the unmixing correction aspect of this, where we go either 0 to 100%, and it'll modify the parameter to parameter interactions. You can also go down here and click on any one of the graphs and say, okay, and it'll highlight which combination it is. So if I wanted to add a little correction, I could take like a 5 or 5%. You see, it just adjusted that. So actually, it looks like that one maybe needed like a negative 5%. It must have been skewed. All right, so we can bring back that plot a little bit. So I like the ability to click on either a plot or a box and have them connect to the other one and say, here's what you're looking at, here's what you're editing, and then have this be parameter by parameter. So for a spectral matrix, that really helps. Okay, so that was compensation. Graphs. All right, so graphs are controlled by whichever group we're looking at is filtering my samples and my populations. So I can look at just the COVID samples, and since we're in by sample in the graph gallery, here's my 5 COVID samples or my 5 flu samples and so forth. We can control parameters we choose by selecting up here. We can control parameters such as just by picking. Let's do forward scatter. Gates are all here. All this is how you would expect it. I'm not going to spend a lot of time on this because this is like all FlowJos. So we'll say like single cells. Okay. You'll see single cells, since I made it on the flu group, is now only on the flu group and is on blue. If I want to move this to another group, I could copy paste. I could drag and drop. So copy. And let's go to good events here and paste. Okay, so now it's purple because it's on all the full stained, and on the flu, it's converted back to purple since now full stained has passed it on down the hierarchy. Again, drag and drop works as well, so you can drag and drop from one place to another within the hierarchy, just like you always have in FlowJo. Double clicking gets you just the events inside, so we could do like a live dead gate. maybe over scatter, something like that. Let's cut out those and spell live correctly. Okay, so I'm not going to spend a lot of time. This works just as you would expect it to work. Um, oh, I should mention that if I wanted to go to like just see the compensated, that is a way to do it right here. So now we're only looking at the comp parameters, but also I tend to work just by searching. Oops, and typoing. Okay, so something like that. All right, so for a given population, we could look at it by parameter. So here's every other combination of parameters for each one of these samples. What's controlling what is shown here is that we are fixing one axis. So at the moment, X is the batch axis and Y is the matched axis to whatever the Y is in the primary plot. So 19 versus each of the other parameters. Okay, we could switch it to back to the Y. So now Y is rotating and X is fixed. And then notice that Y iterates through scatter parameters to start, X does not because I have set my X parameter set to be just the compensated. Uh, so expanding that a little further, I could pick just the functional markers for Y and batch by Y, and we get very few plots that are focused on those functional markers that I made a parameter set from. So I think that helps a lot. If we want to use the color axis, we can switch to a heat map stats plot. This is now active. We could do CD27, for example. So CD27 cells are now bright red. You could then batch the color axis. We get that exact shape plot, but now we're heat mapping all of the other all the other parameters, and we could take the color axis down to just the functional markers. So we get a handful of plots showing where the functional markers are most brightly expressed with, of course, the one that we've selected, just going. Okay. So there is, I think, oh, I should also show that we could do ancestry. So we could pick down to the CD19 population, then show here is the ancestry where I gated on the threes, I gated on the live, I gated on the single cells, and we ran the QC that divided the data up into good and bad based on our various parameters. So ancestry mode enabled, so we can see where a given population came from. Okay, maybe do something like just have a nice picture here for when we do any other kind of drag and drop. All right, cool. So there's that. Let's move on and da, 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 da. Oh, I should show you virtually concatenated. So if I click this button, this is now the virtual concatenation of everything in full stained. So you're working on that. If I go to COVID, now that's the virtual concatenation of everything in COVID. And the numbers here represent that. So that is like 1,000,000 cells in the 319 group. And this test tube button here also controls virtual concatenation. So you could also gate on virtually concatenated data. Oh, I did 38. I think I meant to type just an 8 to start. Oh, maybe not present. All right, well, let's do 427 activated T cells. Cool. Anyway, just picking a particular population, they'll be a little smaller so we can run some t-SNE and clustering results on that with a little more expediency. If I click on that population, it's orange because I just did it on the COVID group and I wanted to run either of these algorithms. I could do t-SNE by selecting the t-SNE button. It will run on all the compensated if I pick that, but I could also go to just my functional markers, do what you will. Um, I can use approximate or exact in terms of measuring the distance between all the numbers. I can use OPSNI if I want. There's webinars on that. That's a good thing. I can choose to downsample. So at the moment, if I'm just using 100,000 events, it'll use 15% of the events and it'll re-upsample the rest. There's other ways to downsample. If I hit submit, I will get a t-SNE plot in 30 seconds or so that will pop up on the screen and show my t-SNE parameters on the X and Y axis having been built using those selections that I just made. So X-shift will work in a similar way. You can click whichever parameter set you want. You can click whatever downsample method you want. There's a handful of options such as angular distance versus Euclidean distance and so forth. Ooh, we are down to the last 5 minutes of this allocated webinar time. Come on, T-SNE, finish up. And then I will quickly show some charts and tables and reports. I have apparently taken my time talking through the program to this point. Oh, I left exact on. I think I generally favor using the approximate as it's a little bit quicker than doing the exact measurement between every couple of cells. I was thinking in my practice run, this went a lot quicker. That's the difference. There we go. Okay. And so I also set it to a relatively small downsample of 100,000 events out of whatever that was running on, almost 700,000. So a little bit of a funky T-SNE when you re-upsample most of the data, when you re-upsample 85% of it. But I think it shows us the major highlights of the data, which we could look through with heat maps and so forth. But we've got 5 minutes left, so let's talk about some other parts of the program. Just flipping back and forth here to see all the data versus one sample at a time. Okay, tables. If I want to make a table, I drag in the particular group that I would like to see as rows, and I can drag in a population such as activated. By default, I am going to get the percent. Oh, I only did those on COVID. So let us drag in, let us take that one out. Actually, I could just copy that. Copy, activate it, and paste here. I must have dropped it. Or it's thinking. Yep, I've set it thinking. Oh, and I'm running out of time. I might just get the spinning color wheel of death. Well, geez, sorry, we've slowed down in the last 5 minutes here to a crawl. I might need to force quit this to make sure we get something done. Yeah, it is bringing up the save. Maybe it's done thinking. Well, let's try. No, I got the force quit. Sorry, we will start that web workspace back up to try to show, and I'll probably go 5 minutes over. So apologies to those who have to go. All right, let us show some tables. Okay, so that ended up doing it. All right, frequency of parent, add it. I added the keyword from keyword and chose conditions so that I had my various conditions in. I will also point out that right here is the default stat of frequency of parent, frequency of total count, and you can select more than one. So you get a variety of things added in. And then your table batches. It's just auto batches. So that's that. You can sort by whatever column you want. And then if you want to go to charts, it'll pick the table as the source. And you've got your condition keyword here that I added and just one stat. So that stat has to be on or else you have nothing. But if you had multiple stats, you could turn on multiple stats, and then you can turn on or off different conditions here. So you could do two-way comparison, three-way comparison, and then you can also, if you want, flip the axis to the other way. So now we're doing frequency of parent live, so just that one statistic, and using color to suss out the combinations. So charts, pretty straightforward. So let's do some reports. And looks like, yes, I think I opened up a different workspace that was already had some reports and charts in it. So I'm going to hit the plus just to get to a fresh report. And then we'll drag a few things in. We'll show a little bit of batching. All right, so going down to full stained. Dragging and dropping things in is the same as it's always been in FlowJo. I will drag in a population. Voila. If you want to make an overlay, you'll just drag and drop two things onto each other. So something like that. I'm going to add a page and make this a page that doesn't batch just by turning off the little gear icon and your assets adding tool is right here. And so I could add in the chart. Let's also go full screen there for that particular page. I could add in the table. I could add in some kind of summary plot from higher upstream. Okay, and going back to the page that'll batch, I could go to my batch controls. I've got the ability to batch by population, to iterate by a variety of keywords, or discriminate by some keywords, change the interval. So like a 2 would take every other sample, but I think I'll take them all. And actually, I don't want that one on there. And just let's do 3 rows by 3 columns. And if I hit the View Batch button, after I move this out of the way of my zoom controls, then I will get a 3 by 3 set of that particular plot going through all of my samples. And you can see that we've got 4 pages now. So it took 3 pages to show all of the different overlays. And then the last page will be my summary page. And so you could order that how you want and so forth and create a report in the format that you'd like it. Okay, that'll do for now. Let me just check the chats and the QA. We are 2 minutes over, so sorry I ended up choosing a much longer running T-SNE than I intended. Okay, and we are good with chats and Q&A questions. So I will say thank you all for attending. We are going to wrap for now, and I'll see you in the future.